Hi everyone, welcome to this unit, Introduction to Databases, CIT 1104. I'm Solomon Cheriot. This is Introduction to Databases, where we shall learn a few things about databases. Among them, Introduction to Databases, Database Components. We shall look at an example of a database, characteristics of a database approach, database users, and a few advantages of using the database approach. Before we look at the core details of databases, there are a few things that we need to remind ourselves about. A few terminologies, a few words that usually come out very strongly during database classes or sessions. So in any particular database environment, you will find yourself talking about database, data, information, and so on. So basically, a database is a collection of related data, a collection of records that is stored within a computer. Basically, you may want to store the data within a computer so that you may want to retrieve them in a future date or for future reference. Data, normally we say data are known facts that can be recorded, and they usually have an implicit meaning until you process them. So basically, data is raw facts. They are raw facts which we can say they don't make sense until they are processed. So a database will store the data as it is, that is raw data, for further processing. Now, a database must exist somewhere. It must exist somewhere within a particular domain in this particular world. For example, in a university, in a school, in an hospital, in a government institution, and so on. We must look at a particular mini world or a small world within the world itself. So for example, we have in a university, for example, we can have databases. A database that will store student details, a database that will store student examination, grades, and so on. So we look at the university as a mini world. You can talk of a library, you can talk of an hospital, you can talk of a government institution, and so on, coming out clearly as a small world or a small domain. While we talk about databases, it is also important to mention what is referred to as a database management system and a database system. A DBMS, which is a database management system, is basically a software that is packaged so that it can be able to allow users or people to store databases, data. So at the end of the day, we need a DBMS that can facilitate the creation of the specific database for a particular domain, for a particular mini world. We need a software that we can use to interact with so that we can be able to create, we can be able to manipulate the data, we can be able to create the database, we can be able to manipulate data that has been keyed in, we can be able to control how the people will use the database or access the database, and so on. So basically, we look at a DBMS being responsible for other functionalities such as authorization and validation checks. For example, who logs in to this particular database, and so on. So a DBMS will monitor all the transactions, all the activities, all the operations within a particular database. So it's very important to know the concepts behind the DBMS. We also have the database system, which is basically the software plus the data. the software that we are talking about, that is the DBMS, plus the data that we are dealing with or we are keying in for a particular domain, which can be a university, which can be an hospital, it can be a library, it can be any particular domain that has or requires some storage of data. So we can also look at the database management system environment, and for us to understand the environment, we require to know the components so that we can relate. In a DBMS environment, we have the following components, which is our hardware, software, we have data, very important, and procedures, plus the people. Basically, when we talk of hardware, we are talking about the physical machine, the physical parts of the computer. We are talking about the machine itself and all the components attached to it, the hard disk, the keyboard, the mice, the screen or the monitor, and so on, printers available, and so on. We also have the software. In this case, we have mentioned the DBMS, and we might even have other integrated software within our hardware or within the computer itself, so that we can be able to access the data that we are using or that we are storing. We also have data which are raw facts, simple raw facts that users will be keying in at the main point of a transaction. It could be a point of sale, it could be at a reception, and so on. Basically, this data gives us a bridge between the people and the hardware and software. Basically, the bridge between the computer and the human beings. We also have procedures, which are rules and regulations, which must be followed. For us to perform a particular task within the database, there must be some rules. For us to access a database, there must be a rule. For example, you should be authorized to access a database before you start working on the data that is stored on the database. So there are procedures. We need to log in, you provide your username, you provide your password, and so on. There are procedures of retrieving data. If it is a query, you can get a query, or you can run a query that extracts a particular set of data. So there are rules that extract that specific set of data. And we have the people also. The people, of course, are human beings who play a very important role in running or in controlling how these machines work, in configuring the software, and so on, keying in the data, designing the database, and so on. So human beings play a role that is very critical in a DBMS environment. We also have, I think we have explained this basically. We also have these components, we have mentioned them, that is the hardware, the software, the data. Basically, what we have on the database, or what has been keyed in on a database schema, which is basically on a structure of a database. We have the software in general, the operating systems, and so on, the hardware, the physical parts. Procedures, we have mentioned the instructions that should be applied when working with a database. Very simple instructions and rules that should be applied when designing or actually making use of that particular database. If it is retrieving of data, then we need to ask ourselves which data is being retrieved. It is based on the procedures that are followed, basically the rules. We also have the people, and when we talk of these people, we have the actors and actors on the scene and those who work behind. We shall be talking about that as we proceed. Before we look at those particular sets of database users, it's important we mention the historical development of the database technology. Earlier, there was a need for a database. Yes, there is always a need for a database, and the need comes in especially when you have large amounts of information or data that you need to store about a particular mini world. If it is a school, if it is a hospital, if it is a company or an organization, you probably require a database. Instead of using files or cabinets to store information, there are advantages, of course, when it comes to database technology or computerized databases compared to having data stored in a file. When you store data in a files will always grow every day. The more the data comes in, the more the file grows. At the end of the day, you might have files filling up the entire room, the entire building, and so on. But when we have database technologies, basically you just need a small device that has enough storage capacity that can be able to handle large amounts, very large amounts of information or data that could have been stored in a very large room physically. So the early database applications, there are two models, hierarchical and the network models. This is based on their structure. Basically, when you look at a network usually has nodes. So you can have a node 1, node 2, node 3, and so on, so that these particular nodes can be able to store information. We also have an hierarchical network or an hierarchical model that takes the form of a tree that is from top and going downwards. So basically, a bulk of the worldwide databases processing still occurs using these particular models. But there are more advanced technologies which have always come up. As you can see, this is a technology that came around in the early 60s. So we also have relational model based systems or database systems which came in around 1970, and this is actually a model that is currently being used, a very important model that is based on relations, where we can be able to relate different entities and reduce redundancies and ensure that there is consistency within our databases. So this was actually experimented within the IBM research and other several universities across the world for it to be noted. We also have relational, we have mentioned that. We also have object-oriented and emerging applications that relate to object orientation. When you talk of objects, basically we are talking about entities, like an entity like a book, for example. A very simple example. A book is just an object. It has several attributes. It has characteristics. A book has an author. A book has an ISBN number. A book has a specific edition, and so on. So in an object, we can be able to extract specific attributes, specific properties, and be able to keep those particular attributes in a particular base or database. So the object-oriented database systems were introduced in the early 80s, 90s to cater for the need of complex data processing in computer-aided design and other applications. Nowadays, it's not only about, as we speak, nowadays it's not only about CAD, but it's also including other applications. So it is a growing area. It is a growing area of database technology. As we have said, the relational DBMSs are still in use today. Now we also have the implementation of a database management system that relates to object-oriented and relational databases. And that's why we have the object relational DBMSs, which is growing also, or an emerging area. We also have extended relational systems, which add further capabilities to our databases. For example, it can be able to handle multimedia data or store multimedia data based on videos, based on images, and so on, and other features of multimedia content. while we talk about databases, it is always important to remember file-based systems. Before the database technologies come in, the file-based systems were in use. And of course, these file-based systems, just like a manual file, you will have a file meant for a specific entity, and that particular file will always store data or information for that specific entity only. One thing about it, no relations or no relationships. So file-based systems basically are a collection of application programs that perform services for the end users. And we know, or we can say that each program defines and manages its own data. And that's why we are seeing each program will have a file that has some data. And each file will have the data for a specific entity alone. So these file-based systems were important, but there were so many disadvantages about them. And that's why actually the DBMS or database management systems kept growing, so that we can have the relational models, we can have the object-oriented models, and so on. When we look at file-based processing, it's very simple. If you look at a department, for example, you can have a department keeping a file for that department. It can have a sales department, we can have the contacts file somewhere, we can have a sales file from the sales department, and so on. For the customer care, we can talk of contracts and so on. That is our contracts. We can talk of any department within an organization, whether it is accounting, whether it is a human resource, and so on. So within an organization, each specific department will have to keep its own data using its own programs, using specific applications. And of course, you need to store that particular information somewhere using the files now. So these files will store information. For example, the sales files will have information or data about the sales department. We can also talk of contracts, we can talk of HR, you can talk of the accounting department, manufacturing, planning, and so on, finance, and so on, where each of them will have its own files separately, which means they are distinct, they cannot be related to any other. So many disadvantages with this, as we shall see next. So while we talk about these particular small files or files relating to departments, you can have, for example, in the sales file, you can have some few fields or some few data relating to, for example, to property for sales, private owner, and client. Look at the property for rent and look at the property for rent within this file and this particular file. Remember, these are two files. If we are talking about a big organization, we can be talking about maybe 15 files, for example. So sales, contracts files, we have financial files, we have accounting files, and so on, human resource files, just to name a few. Some of these particular records will be able to repeat across all the files, making our files or our storage less and less, and making our files very big at the end of the day. So there are limitations when it comes to file-based approach to keeping records. There is always separation and isolation of data, because each program or each application will be able to manage or maintain its own set of data. And users of one program may be unaware of potentially useful data that is being held by another file. That is very critical. It doesn't make sense to have important data in another file that can make a lot of, that can help a particular department, for example, to make decisions. So there is always separation and isolation of data, where It's like we have a boundary. We cannot access the data that is in another file. Simple, because there is no relation, or there is no relationship between file A and file B. Again, we have mentioned this duplication of data. The same data is being held by different programs. The same data is being stored in file A, like property for rent in file A and file B. That one brings in a lot of issues. Number one, for example, there is wasted space. Remember, we always want to optimize the use of computing resources, and the more we duplicate data, the more we waste space. And of course, when we also have duplication of data, we have a problem in terms of updates. So it's very difficult to update data. If you have data stored in 10 files and you update in one file, it means you have to go through all the 10 files. That can be cumbersome, and you can even forget a particular file. Again, there is data dependence. The file structure is defined in the program code. This is a disadvantage, because if we change the program or the file structure, it means we might even change the way we might start adding new data to our file. That is a big disadvantage, especially when we shall compare it to the database approach. We also have incompatible file formats. You might have a file that is stored in one location, and if another department would like to use that particular file, the systems might not be compatible, or the file might not be compatible with another computing environment for another particular department. So this is because these files are usually generated using different applications. The files can be generated using different applications. And of course, when you talk of different applications, we can come up with applications using different languages. And therefore, communication becomes a barrier. We also have fixed queries and proliferation of application programs. Here we are talking about, we can say that programs are written to satisfy a particular function, and any new requirement needs a new program. So unlike the database approach, for example, where queries are not fixed, because you can always run a query from any particular platform and satisfy the needs of a particular requirement. For this particular case, you have to write a particular instruction to fit only a specific function or requirement for that particular file. The same, you cannot use the same instruction in another file or to meet another requirement. If you want to write another query, it means you have to rewrite the entire program for that new environment. So looking at these disadvantages, there is a need to have a database system where we have the database, and we have the DBMS, and we also have the data. So when we talk of the database systems approach, basically we are looking at an approach that uses the database management system. As we have said earlier, this one came around in around 60s or 1960s, basically to overcome the challenges that were being faced while using the file-based approach. While we talk about databases, it's important for us to look at, or to just to mention examples of database applications. Every day we interact with systems. Every day we interact with systems. While you interact with a system, always remember that there is a database running in the background. There is always a database running in the background. If you are in the supermarket, for example, there is a database that keeps records of the products, their prices, and so on. It also keeps the records about who is currently serving or who is currently on at the point of sale terminal, and so on. Purchases using mobile phones, for example. So mobile phone transactions, also there is a database running at the background. So basically that's an example. Booking for an holiday, you want to travel somewhere, you can always book online, and so on. You will be accessing a database, and so on. Studying at a university, you register units, you check your results online, and so on. Local library, there's a database that keeps record of all the database of all the books, for example, within the library, all the users, and so on. How long have you stayed with a particular book? Is this book a special or just an ordinary book? So this information can be easily retrieved if and only if we are using a database application. This is just a simplified database environment to prepare us to look at what we call the database architecture. While we use a database, we end up being called users. We can also be what we call database designers, database programmers, and so on. So basically we use some applications. We interact using some applications on the front end. In between or just after your application, there is a DBMS software which we might not actually feel it as users. But it's a very powerful software that actually makes sure that what we need, we get what we need. So these DBMSs will always process the queries, it will always access the data. And where is the data stored? Of course, in a particular storage device. It could be an hard disk, it could be some specific storage device, and so on. It could be the cloud, and so on. So it doesn't matter. The DBMS will get you the data. It will store the data. It will retrieve the data for you while you interact with some application. This gives us an idea or a platform to discuss what is called the DBMS architecture. The DBMS architecture has 3 levels, namely the external level, the conceptual level, and the internal level. The external level, basically, this is where we have applications. At the top here, we have you and me, that is the users. So we have the applications that we are using to interact. It could be a browser, you are accessing some online products, and so on. You are registering units, and so on. We also have a DBMS, which we have said it will give you or retrieve data or process your instructions. And basically, we have the database. We have the database which keeps all the records. So for the records which are stored here, for you to see them, there must be a DBMS. For the data that you are keying in to be stored in this database, there must be a DBMS. We have 2 areas also in terms of data independence, physical and logical. Remember, we said in file-based that we talk about data dependence. When it comes to database approach, we talk of data independence. Basically, the role of DBMS in any environment is to define a particular database in terms of its data types, basically its structure, or to structure it, its structure and constraints. For example, if I am creating a database for a particular environment, for a school, for example, I need to define the kind of data types the data will use. If it is an admission number, for example, admission number can have letters, it can have numbers, for example. That means I need to know what kind of data type I'm going to use to store admission number. If it is a phone number, I need to know what kind of data type will be used to store or to hold admission or mobile phone number, and so on. So at the end of the day, when we are designing a database, we define its data types, the structure, and the constraints or rules for that particular database, and the structure, how will the database look like. We also use the DBMS, of course, to construct or load the initial database contents on a secondary storage medium. Basically, we want to use the DBMS to allow data entry and storage of the same. So while we key in data, we also require the DBMS to allow the storage of that particular set of data that we are keying in. The DBMS also is responsible for data manipulation, whether we are modifying the data, we are retrieving the data, or we are accessing the database through some application. It could be a web application or a particular application. So while we talk of data manipulation, we are talking about retrieval, we are talking about modification, we are talking about access. We can query and generate reports while we retrieve information. You can check, for example, your credit. For example, if you're in your mobile phone, it means you are retrieving some information that is stored somewhere. Basically, you are querying a database. You can modify. You can modify your name, your password, and so on. You can create new set of data within your platform, if it is a portal, if it is your environment within a certain information system, and so on. And of course, while you all do this, all these things, you access the database. The DBMS also allows us to process and share data that is stored in a particular location, that is a storage media, and not just a single person, but the DBMS will allow even hundreds of people to access the same information concurrently at the same time, simultaneously, while it keeps all the data valid and consistent. So it can be able to monitor. Its DBMSs are very powerful. They can monitor what users are doing, whether you are editing or you are just viewing. If several people are editing the same data, the DBMS must be able to control that particular set of data so that at the end of the day, we have a consistent set of data within the database. Apart from those few features of a DBMS, we also have security, securing the database. Of course, we need to ensure that the database is secure, and we need to prevent unauthorized access. And therefore, that's why when you are accessing any system, you usually find yourself in an environment where you key in a username and a password. Those are the most basic authorization techniques. So other features also include presentation, visualization in graphs. For example, you can present data in some graphs so that somebody can be able to know maybe the growth of a particular set of relations within the database. You can also look at visualize two sets of products. How is product A faring on? How is product B faring on within a given time period? So the DBMS can also, it depends on the kind of DBMS that you are using. You can be able to know how many people have logged in to your web, and how many people have accessed a particular set of data, and so on. So the DBMS can provide more powerful functionalities depending on which database or DBMS you are dealing with. So basically, the DBMS is very critical, and there are so many examples of DBMSs. A database management system, for example, the simplest and mostly accessed, Microsoft Access. We have SQL, we have Oracle, and so on. There is a wide range of these particular products available within the market. Let's look at a small conceptual data model of a domain, a university domain, or a mini world for a university, mini world. Within a university, we might need to store data. Yes, it is relevant to store data. Why? Because we want to keep records for future reference and for ease of processing, currently and in future. So we have, in this mini world, we can create small entities like students, courses, units of particular courses. We have departments, we have instructors, we have lecturers, and so on. We can create small entities within this particular domain. If you think of an hospital, think of a particular domain where you visit and start interacting with people where there is a structure. If it is an hospital, for example, you start to think of doctors, nurses, medicine, patients, and so on, departments, and so on. Within this particular university mini world, we can talk of relations. We can talk of relations. This is just an example, a conceptual data model. It's not very specific, but we know that units are for specific courses, so that creates a relation. And that's why we talk of relations actually beating file-based systems. Without these relations, then we'll be talking about independent files, and that will directly lead us to file-based storage, where we can have a file for units only, file for students only, without relations. But the moment we start talking about database approach, it means we are bringing in a new element, and that is the concept of relations. So units are for specific courses. We know that a unit is actually on its own, and we know that a course is on its own. But the moment we talk about database approaches, we can bring in a relation. And when you are going to design a database, you can be able to create these relations. We can have the course unit code, for example, for this unit, and this course, the courses, we can have so many courses within a university or within a learning institution, so many courses, each course having its own units. And of course, we know that students have to take the units. So we can see clearly that we are now creating some form of relations. Students are taking units that are of specific courses. It's very simple to design this when it comes to databases. Very simple, because there are tools to do that particular task. There are tools to create the relations themselves. So it's just a conceptual view. We need to understand how things actually work out within the database. We know that courses have prerequisite courses. You might, for you to do a particular course, you might be asked, have you done this before? So probably, if it is a yes, then you can take that course. Then we have instructors or lecturers teaching units. We have courses being offered by departments. We have students belonging to specific departments. We can see the whole mini world is now related. One entity is related to another. So these particular entities are expressed in a conceptual data model, such as you can easily draw this using what we call ERD, that is an entity relationship diagram, because of an entity relation or entity relationship. So very simple. In every particular domain or mini world, you can be able to relate different entities. And once you relate them, you can be able to actually start the design process of a database. Characteristics of a database approach, we have talked about disadvantages or limitations of the file-based approach. Now, when it comes to database approach, the advantages actually are very many. The advantages, that makes it a very powerful technology to use compared to file-based approach. So basically, a DBMS will let you store everything about the data. For example, it can allow you to store even data about the data itself. It can allow you to store data about data. That is the data that is describing the data. For example, you can have in a database, you can have a section for a student name. Then you can have a section that describes the field student name or first name. So we can have admission number, you can have mobile number, you can have a date of birth. Then we can have a column for describing those particular fields. Date of birth of a student, that is a description, that is metadata. This actually will allow the DBMS software to work in different database applications, because we can carry the structure and carry the descriptive nature of the data. So a DBMS catalog will store the description of particular databases, which include the data types, the rules, the structure of the database, and so on. Very, very important. We also have insulation between programs and data. Earlier, we talked about file-based systems. We add data dependence in file-based systems. In database approach, we have data independence, and we have seen in the database architecture that we have logical data independence and physical data independence. So actually, for this case, this allows changing data structures and storage organization without having to change the DBMS access programs. Earlier we said with the file-based systems, if you have to change something, then you might have to change the entire environment. You might have to change the entire environment. So in our case here, if you are just changing a particular application, you don't have to change the data structure. If you are changing the data structure, you don't have to change the application or the behavior of the application. That is called program and data independence. We also have data abstraction, which is basically, we can talk of a data model is usually used to hide the storage details. So nobody even would want to ask you what kind of a database are you using, because we have what we call abstraction, where we try to hide the general details. We try to hide the storage details of a particular storage environment and only deal with the essential details. So when you are dealing with different sets of DBMSs, you might only want to look at the essential details, but not the specific details of a particular entity. So this will give us or this will present the users with a conceptual view of the database. Very simple. Our programs will always refer to the data model constructs rather than the data storage details. That's what we have just mentioned. So you just look at the structure because you are focusing on the essential details rather than how the storage device will work. We also have support for multiple views of the data. Unlike file-based systems where we look at the entire view singly or in one view, when we are using the database approach, we can break down the view of the data such that we can have even different levels. We can have, for example, we have the administrator and the user. The administrator can view everything, while the basic user can just view a specific section of the data that is related to that specific user. If you are in a database for a university, for example, if you are a student, you can only view your student details, you view the units, you register the units, but there are things that you cannot view that relate to the other departments, like you cannot change financial details and so on, because those who change financial details belong to another view, that is the finance department, for example, while updating your fee payments and so on. If you are talking about the HODs can be able to view all your recorded units or registered units, and in such a case can make some alterations, for example. But some views for users or for a student, you might not do any particular change. So this particular flexibility gives the database approach a very powerful capabilities, where you only view data that is interested to your case or to your type. We also have another characteristic, that is sharing of data and multi-user transaction processing. While we use DBMS, we intend the DBMS to be used by so many users. A student, a university system, for example, we expect maybe 10,000 students to log in to the same system. That is what we say concurrent access. Concurrent access means there are so many people accessing or retrieving information from a single location. So the DBMS or the database management systems that are in place are capable of allowing concurrency, and it's able to control that particular concurrency, where people can be able to transact, can be able to access, even retrieve, and even more, to change or update the database details. So if we have 50 people accessing the same file and making a particular change, or maybe 5 making a change, the DBMS will always ensure that at the end of the day, the changes that are made are consistent. So it can be able to provide some mechanisms for locking. For example, it can lock access or lock editing and so on until a particular set of processes have been completed by another user, then release that particular process and execute it. So there are several things that we need to refer when we are talking about concurrency. We also look at recovery, where a recovery subsystem ensures that each completed transaction has its effects permanently recorded in the database. This ensures that we have data forever. We have data for future reference, and we can always say forever because you can have data stored for a very, very, very long time. These are just but a few of the characteristics of the database approach. There are so many others in terms of, for example, redundancy, consistency, and so on, security, and so on. There are so many advantages that relate to the characteristics that go together with this database approach. We had mentioned earlier about the database users or the people within a database environment. And we said that there are those people who are actors on the scene, and we also have workers behind the scene. When we talk of, these are just two categories, but remember we shall still break them down specifically so that we can have different sets of users. When you talk of the actors on the scene, we are looking at those people who actually use and control the database content, those who design and develop and maintain the database applications. The people who use and control the database content, they design, they develop and maintain the database applications. Those are actors on the scene within the environment. Now, we also have those people who design and develop the DBMS software and related tools. These are people who we refer to as workers behind the scene. So most of the time, we'll find ourselves on the scene where we create the database, where we put in content, we maintain the database, we update the database, we do a lot of things within the database. And this database is stored or is held within a DBMS, which is actually updated frequently by workers behind the scene. Going back to the actors on the scene, which is our main area of concern, we have the database administrators, we have the database designers. These are two different people. We have the database administrator who actually monitors and coordinates all the activities that other users will be doing within a particular database environment. For example, who accesses what? You can set, for example, the database administrator can set the rights for a particular file or for a particular record. You can say some people can modify the record, some people can only read, and so on. We also have the database designers. These are actually the people who define the content, the structure. So these are the people who will tell you, we will have 5 columns in this table. We will have the first name here, we will have second name here, we will have mobile phone number here, we will have email here, we will have the course here, and so on. These are the designers. The administrator will come in later, or will come in when the structure is already ready, it's ready for use, it is running, and so on. So the database designers, again, each one of these plays a very important role. But as a database designer, for this session, we shall be mostly within this area, that is the design of a database. So it's very important to take note of the two, administration and design. We also have actors on the scene. The actors on the scene continued, that is, we have had database administration, we have had database designers, and we also have the end users. Basically, the end users will key in data. Some of them will query the database that is already there. Some of them will generate reports, and so on. While you key in data, basically you are updating the database content, and so on. We have several categories of end users. We have the casual, we have the naive or parametric, and we also have standalone and sophisticated end users. For casual, these are actually a group of end users who access the database occasionally, not every day. They only access the database when there is a need to access that particular database. So it's not an everyday task. We also have parametric end users. We can say that they make up a large section of the end users. They use previously well-defined functions in the form of canned transactions against the database. Examples are people who work or who use the database or use an application on the front end of an information system, like the bank tellers, the reservation clerks, and so on. So in a big information system, these are the people who make use of that particular system every day to key in data or update the database content and so on. Create a query, and after creating a query, generate a report, and so on. If you want a statement, you can be able to get it in terms of a report. So we also have sophisticated users. So we already have the sophisticated and standalone. Now, when we talk of sophisticated users, we are talking about business analysts, engineers, scientists, and so on. This group of people will actually use tools or specific software packages to work closely with the database. They could be doing some analysis. They could be retrieving data so that they can be able to perform some analysis on a particular topic, and so on. So very specific group of people. Most of these people will not work with the database every day like the bank tellers. And we have the standalone group. These people will always maintain the personal databases or using ready to use packaged applications. Look at a person, you might have an internal database of your own, for example, an address book, and so on. You can create your own database and manage it on your own, using your mobile phone, using your computer, and so on, based on your events within your calendar or your schedule. So most of these people will maintain their own databases, standalone databases within their own devices. Based on the database approach, we have mentioned some of these particular, based on database approach, we have mentioned characteristics of a database approach, and they directly relate to the advantages, or what the characteristics will bring you the advantages or the benefits. So we can control redundancy, for example, in our data storage. Remember, in a file-based system, we can replicate or we can repeat some data in several files. In this case, we can have or we can control redundancy. For example, when you are controlling redundancy in data storage and in development and maintenance efforts, basically we want to ensure that if you are running a system in a certain point, we can ensure that that particular system is running in another location. So in that particular case, we can ensure that we can have multiple people sharing the same database. So instead of us having a database in Nairobi, in having a database in New York, having another one in Cape Town, and so on, we can just use the DBMS approach and control redundancy by providing this access to multiple people using a networked environment, which is very crucial. We can provide a network, a particular type of network, which can be implemented so that people across can be able to share the same database. Again, this is for security. We can restrict unauthorized access. We have repeated that. We have mentioned that. We can provide the use of passwords, usernames, and so on. That is one advantage again. We can also talk of queries. Yeah, we can provide what we call storage structures, where we can index the data in the database. Indexing gives you a very fast, efficient query processing mechanism where you can retrieve data very fast, because we have very good storage structures, which indexes are one of the examples. Another advantage with this advantage of our database approach is we can provide backup and recovery services in case there is a failure or we anticipate a failure. We can do backups regularly, weekly, daily, monthly, and so on. In case there is a failure, we can recover very quickly. We can also provide different views. We can provide different views. Remember, we talked about multiple views. We can provide different views for multiple users depending on their levels of access to the database. We also we can represent relationships, complex relationships among data. We have tools to do that. There are tools to represent complex relationships between the data that is being stored or the data within a domain or mini world. So the DBMS will give you tools to represent a very complex relationship in a very simple way. We can enforce integrity constraints on the database. We can say that if we are able to delete data in one location, we can delete the same in all the locations. Or we can say, if we delete in one location, we can keep in one location. It is upon the database designer to ensure that the constraints are very clear or well laid out. We can also make decisions. We can draw inferences and actions from the stored data using deductive and active rules. So based on the rules which have been set by the designer, we can say that we can retrieve this data and generate a report. And at the end of the day, we make decisions, or we know the next course of action to take based on the report or the summary that has been provided after we followed a certain set of rules to extract some data. We also have the impact of using technology. If you are able to implement database technologies, there are several things that, of course, will come into play within your environment. So we also have, number one, we talk of potential for enforcing standards. So within your own environment, unlike the file-based approach where different organizations can bring in different standards of their own, we can enforce even an international standard of referring to items or referring to entities, referring to data types, and so on. So this is very crucial for the success of database applications in organizations. With standards here, basically we are referring to data items, we are referring to display formats, the report structure, the metadata, and so on. So we can always say that we want all our data or all our outputs to be presented in this manner. And that becomes a standard. And that becomes a standard. We want all the data formats to be in this case. We want the reports to be in this case, and so on. And we can always follow the same while we are designing the database. While we also use the application, that is our database approach, there is always reduced application development time because we already have powerful tools within the DBMS. So adding new applications or creating even new applications, the time it takes to create a new application or to add a new application within an existing system is reduced drastically, because you just do an update. We also have flexibility to change the data structures. You can change data structures. Remember what we talked of in terms of independence. The database structure may evolve as new requirements are defined. That is natural in any environment. So as changes come in, you can always make the changes and upgrade your data base and bring in new changes or reduce or even remove some things without affecting the entire functionality of the DBMS. Of course, we can always provide new current information anytime, for example, in real time. So it is extremely important for online transaction systems to give information that is current, and for these particular information systems to always be available. So availability is critical, and availability of current information is also very important. Current information, where you can log into a particular portal and get information directly about that particular environment. We also have economies of scales, scale. When you talk of economies of scale, of course, a DBMS can actually save costs within an organization, where we can be able to reduce wastage and so on. The cost of keeping records in different locations, of employing different people to look after the data and so on can be avoided, because we can have a consolidated environment. We can have a single environment where all the data is kept in a single environment. That is basically the DBMS itself. So there are so many roles, or there are so many things that actually come with the implementation of a database approach compared to file-based approach, or even the traditional way of just keeping records in a room. So the DBMS approach is actually proving to be strong, and the future looks extremely bright for database approach, because there are technologies which are coming up so that this particular area can be researched, and new features or new technologies can be implemented. Think of the cloud, think of clusters within virtual environment and so on. So there are so many emerging trends within this particular area, and that gives us an assignment or some homework for us to think or to work on as we think about the top trends in database management technologies. So basically, you just need to look at the emerging trends of databases or database technologies, so that we can be able to understand in the next 10 years, in the next 2 years, in the next 5 years, what kind of technologies might be around within our working environment or within our learning environment. There are so many of them, so you can pick a few, at least 6. So that takes it or wraps it up for this week. Let's meet in our next lesson.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.